Hello dear students, welcome to my channel Chemistry with Chemist. So today I have come up with a new topic, that is periodic table. So this topic, I hope you understand the concept which I have given in this chapter. So before that, I request all of my viewers to kindly subscribe my channel. So without wasting much time, today we are going to start with the two last topic of this chapter. The first one that we have today is electron affinity. Okay, now let's come to the definition first, students. The amount of energy, it's amount of energy released on adding an electron to a neutral isolated gaseous atom. Why neutral isolated gaseous atom? I have already discussed with you when I was teaching you ionization potential. If you have not seen the video, I request my viewers to please go back to my previous video and understand what is neutral isolated gaseous atom. Okay, now it is the amount of energy released. So I will take one example. See, suppose you have got chlorine here. So we have 7 electrons in the outermost shell of chlorine. So when you add 1 electron for chlorine here, then it becomes 8 electron. Am I clear? So what is chlorine doing? Chlorine is getting an octet configuration. So what kind of configuration is this? This is a stable configuration. Am I clear? So that means when chlorine is gaining electron, it is becoming stable. So what happens when you become stable? You become stable means your energy level decreases. Am I clear? Once again I am repeating. When you become stable means your energy level decreases. So what happens to the extra amount of energy? This is liberated. And what is this energy known as? This is known as electron affinity. Am I clear? So when you become stable, energy level decreases. What happens to this energy? This energy is released. And what is this energy known as? It is known as electron affinity. Okay, so let's move on to the next part. Now this is the trend of electron affinity. Okay, now when you move from left to right, electron affinity increases, and when you move from top to bottom, electron affinity decreases. Am I clear, students? So let's take few examples and try to understand. Okay, so I have a broad periodic table for you here in order to make it easy for you to understand. If you come to this side elements, that is lithium, and if you look at fluorine, then when you are moving from left to right, what happens to affinity? It increases. That means fluorine has more electron affinity compared to lithium. Am I clear? And when you move from top to bottom, what happens to affinity? It decreases. Understood? So in this way you can compare or you can remember electron affinity trend using the periodic table. Okay, dear students, now I have come up here with one example better, where I'll be discussing with you from left to right. Okay, the trend of electron affinity. This is the example. So I have taken example of sodium, which is on the extreme left, and I have taken example of chlorine here, which is on the extreme right. Now let's see how or why it increases the electron affinity value. If you come to sodium, there is 1 electron. I have taken one more example. Aluminium, there are 3 electrons. Sulfur, there is 1, 2, 3, 4, 5, 6 electrons, and chlorine, there are 7 electrons. Now you think of a race. Okay, you think of a race between 4 different runners, right? Now this runner, the one which is going to come first, will be very happy person, right? Because he is the winner. The one which comes second will be happy, but he will not be happy as compared to the first, because he is the first runner up. Got it? The one which comes third will be happy, but he will not happy compared to the second or compared to the first. Why? Because he is the second runner up. Got it? And the person which come last will be the least happiest. Why? Because he could not win the race. So let's compare happiness with this example here. Now see, sodium, we are talking of a situation where we are adding electrons. So do not confuse yourself with electrons releasing. Okay, this is not a releasing part. When you are releasing electron, this is ionization potential. Okay, students, and when you are adding electrons, this is electron affinity. Got it? So in sodium you add 1 electron, so that means sodium will get 2 electron configuration. But to become stable, how much more you need? You need 6 more. Got it? Come to aluminium, it has got 3 electron, you add 1 more, So it has got 4 electron. To complete octet you need 4 more electrons. Come to sulfur, you add one more, it will gain 7 electrons. So to complete octet it will need one more electron. And come to chlorine, you add one electron, it will gain octet configuration. Now let's imagine this example which I have given. Let's apply here. Sodium has got one electron, it is 6 away from getting octet, so it is not that much happy because it is 6 away from getting octet. Come to aluminium, it is 4 away from getting octet. Got it? So it is happy but less, sorry, it is more happy than sodium because it needs only 4. Okay, but it is not that much happy because it needs further 4. Okay, now come to sulfur. Sulfur has got one electron and it has now 7 electron configuration. That means it only needs one more electron. Now if you look at sulfur, sulfur is quite very happy by gaining this electron. Why? Because it is very close to octet now. Okay, and come to chlorine, it got one electron, it is octet now. That means chlorine is the most happiest. That means which one will become more stable? Chlorine. Am I clear? Which one is less stable? Sodium. Why? Because sodium is less happy and chlorine is more happy. If chlorine is more happy, which one will release more energy due to stability? Yes, students, it is chlorine which will release more energy because it is very happy, it is very stable, and chlorine will release, sodium will release less energy because it is less happy due to less stability. That means which one is going to have more electron affinity? It is chlorine. And which one is going to have the least affinity? It is sodium. So in this way, students, you can compare happiness, okay, with the amount of energy released and the stability of elements. Am I clear to all of you, students? If you are not able to understand, please comment me in my video below. Okay, now let's come to top to bottom. When you move from top to bottom, then what we have is, see, I have got fluorine, chlorine and bromine as the example. Now here you have to remember one thing, that there is an exception of fluorine and chlorine. Okay, but this exception you don't have to remember right now for class 10 examination. So let's go with the usual trend. Okay, let's not come to any exception right now. When you move from top to bottom, I have already said you that the number of cell increases. Okay, so fluorine has 2,7 yes, 7. It is 287. This is 2887. That means there are 4 shells here, there is 3 and there is 2 shell. Okay, now let us think of the nucleus. Nucleus is here. Now this nucleus is binding all the 7 electron. Okay, in all the cases. Now we are talking about a situation, electron affinity means where you add one electron. So let's add one electron here, let's add one electron here, and let's add one electron here, and let's analyze the situation. Now fluorine has a very small size, so all the electrons are very close to each other. Okay, am I clear? Now you add one more electron here, what will happen is this electron will come in this orbit and this nucleus is very close to the orbit. Okay, the nucleus is very close to the outermost orbit. So what this nucleus can do, this nucleus can hold this electron in an efficient manner. Okay, when I was teaching you non-metals, that time I have discussed about this situation. If you have not seen my video yet on non-metals, please go back and check the video, guys. Now if you bring this electron here, chlorine has got 3 cells. So what happens to the size? The size is big. So compared to nucleus and electron distance, it is much larger, or okay, as compared to fluorine. This length is longer compared to the length of fluorine. Now if you look at bromine, the size is further big due to increasing number of cells. So when you are adding one electron here, this nucleus is further far away from the electrons. That means, how can I interpret this situation? I can say that this bromine nucleus cannot bind this electron properly due to longer distance, and this fluorine can bind this electron properly due to shorter distance. Am I clear? So that means this fluorine is more happy gaining the electron. That is why it will release more energy, and this bromine is less happy gaining the electron. because it is not able to bind properly due to longer distance, so this is less happy, so this will release less energy and fluorine will release more energy. That is why when you move from top to bottom, your electron affinity decreases. I hope students I could make it clear to all of you. Okay dear students, now let's move on to the last topic, that is electronegativity. Now we don't have to learn much about electronegativity and we don't have to understand like in depth, okay? Only let's understand the definition and trend. Okay, now the definition says it is the tendency of element to attract shared pair of electrons, okay, from a covalent bond. Now let me take one example of hydrogen. Let's take this example. Let me think that one electron is shared and there is one chlorine which has, okay, one electron is shared and remaining 7 electrons are present here and hydrogen has 1 electron here. So this is nothing but HCl bond, okay, a covalent bond. Now when the bond is formed between these two things, then it is very obvious that the shared electron should be in the middle, center, okay, here like this, center. But this chlorine, that means the elements which are present on the right hand side, okay, as compared to elements on left hand side, once again I am saying elements which are present on the right hand side, they have more electron affinity. That means just now I have taught you that they have a tendency to attract electrons, okay. The same situation is going to prevail here also. This chlorine, what will do is it will try to attract this shared pair of electron towards itself. It will try to dominate hydrogen and try to attract this shared pair of electron towards itself. So what will happen? This shared pair of electron now will go very close to chlorine and it is far away from hydrogen. Am I clear? This situation is known as electronegativity. And what will be the result of this? See, result is very simple. What is chlorine attracting? It is attracting electrons. That means chlorine will attract negative charge, or it will gain negative charge, and hydrogen will now gain positive charge. Why? Because the electron is far away from hydrogen and very close to chlorine. So this kind of property where you attract or where you pull the shared electron towards yourself, this is known as electronegativity. It's very simple, dear students. Now the trend of electronegativity and electron affinity is same, okay. So you can just check the trend of electron affinity and it is going to be the same. That means left to right it increases and top to bottom it decreases. Am I clear? Okay dear students, I have come up with 2-3 questions for you here, okay. You can take a screenshot of this and you can try solving these questions at home, okay. If you are not able to solve, please do comment me below my video, okay. Few more questions are there. I request all of you to take the screenshot. I brought few more questions, okay. These are all board questions, got it? Okay, this is the last one. Please do practice these questions at home and I hope all of you will get the correct answer. Thank you for watching my channel, dear students. Please do not forget to subscribe my channel, share this video as much as you can, and please do like my video. Thank you dear students once again.